Hello and welcome to the Voice of Standard Users, a podcast brought to you by iPhone. I'm Chaim Oren, your host, and in each episode, I speak with leaders who are shaping industries around the globe through the use of standards in practice. I'm happy to introduce our today's guest, Mr. Alton Sanders from Boeing. Mr. Sanders is an associate technical fellow and a designated expert for standards management at the Boeing company. The focus of his 40-year career has been on improving the quality and value of standards and transition standards from documents to digital data. Alton's accomplishments at Boeing have been recognized with industry awards such as a Computer World Honors Program laureate, and a Progressive Manufacturers High Achiever for Innovation Mastery. Mr. Sanders is the founder and the chair of the Digital Standards Alliance Consortium. He is a 7-year member of the American National Standards Institute Executive Standards Council, and he is also a member of IFAN. Welcome to our podcast, Alton.
Oh, it's my pleasure. Thank you for the invitation.
Sure. So I would like to start our conversation by asking you, how did your professional journey lead you to Boeing? And when did you first feel the real responsibility that comes with your aerospace work?
Oh, that's a great question. Well, I really started out at McDonnell Douglas Aircraft Company in St. Louis, Missouri, right out of college. And it was at a time, well, let me say that McDonnell Douglas in St. Louis was a military aircraft fighter jet manufacturer.
Yeah.
And I grew up in the St. Louis area. They were very busy with several programs at the time. And so they were doing a lot of hiring. And so I just got out of college, luckily, at the right time to go work for a company. But I hadn't really had ambitions about being in aerospace. I didn't even really know very much about McDonnell Douglas. In fact, I saw my interview results sheet about a year after the interview was over, and it said, "This person is a great student, but they know nothing about our company, but they hired me anyway." So I was glad to just have the job. I didn't intentionally move in that way. Later on, in the late 1990s, McDonnell Douglas and Boeing merged into one company. So I've been with the same operation the whole time, and I was hired into what McDonnell Douglas called the standards department. So my career has had this standards focus my entire time here. Now you ask, when did it really seem to have some sort of real meaning for me?
Yeah.
And I would say that when, well, there were a couple of things. Early in my career, we were developing an aircraft, and I was asked to work on some of the lighting panels that went into what we call the crew station. Some people call it the cockpit. And, it was a big source of pride for me that these buttons and knobs and light bulbs that I was putting in the design, were things that every pilot needed to interact with every single time, and for a fresh out of college person, this was very satisfying. I felt very proud of that. So that in and of itself, I got started out in a way that I really felt like I was doing something that made a difference, and I had a source of pride in my work. The other thing is that shortly after I got hired, we had the first space shuttle disaster, and I think it was Columbia, exploded on takeoff, and all these lives were lost. It was a terrible tragedy, but a lot of the research into why that happened boiled down to the failure of an O-ring. And
Wow.
in my and I mean, if you really study the whole thing, it's not really the O-ring's fault. It was asked to do something it wasn't supposed to do. But that was the kind of things that I was doing at the company. I was working on small parts like light bulbs and connectors and O-rings and washers and nuts and fasteners. And so it really became very meaningful to me that all these little things that I work with, while they might seem like small pieces of something far grander, it only takes one of these small pieces to not be
Exactly.
well
Yeah.
designed or well engineered or have good sources. And so everything I put into these standards had to be really, really, perfect. And so it
Mm,
drove home a real sense to me that this was a life and death decision, and I should not be careless about anything that I did in my work and standards. So that is
wow.
that's really where it hit me, and that's how I got to really uh, get started in that part of the space.
Great story. So, can you recall a moment in your career when safety was not theoretical but deeply personal? What
Mm,
role did standards play in this moment?
mm. Well, yeah, the shuttle thing. Well, although that wasn't a McDonnell Douglas product at the time, but you know, sadly, tragically, there are accidents and problems that have happened in aerospace, not just Boeing aircraft, but in many others. And sometimes when they go back and do the research and really try to understand what happened, it was something wasn't done exactly per the specification and the standard that said how it had to be installed or tested or verified that something happened. And you think in normal everyday business, everybody does the job, they do the job the same way, things are supposed to, and they're performing well in the field, but um, the instructions that we write down as standards on how to manufacture something, whether that's how to assemble something or how to create a part by machining it or forging
Mm,
it or something like that, all the specifications we write for that, um, they're very, everything is critical. There's nothing that's not,
wow.
critical, in safety. I mean, you might say that in the cabin of an airplane, maybe my little screen that lets me play a video game isn't so critical, but there are everything else about what holds the plane together and makes it propel. All these decisions are critical. So the parts, the way that they're held together, the way that parts are manufactured and formed, the quality that inspections that go into the materials themselves that get used, in the product. It's it's just pervasive. At my company, we estimate that 40% of the definition of an airplane comes from standards. 40%
Wow.
of your product definition. Yeah.
Very
And
significant.
what
Yeah.
designers are doing is just let's take this metal, which has been defined by a standard, and you know, machine it per some standard manufacturing process, and then let's install a fastener per a fastener installation process. And those fasteners themselves are written to standards, and you're using standard tooling to get the job done. And a lot of what makes one plane different from the other is the other 60% of the design, but they're building blocks for all airplanes, right? is
Mm.
is a pretty solid core of materials, of parts, and manufacturing processes. Now sometimes you get new processes that weren't used in the past. 3D printing is an example of something that's come along recently that we didn't have in the 60s, 70s, 80s. but and there's always other technologies that are being explored and applied in different ways. Even composite materials that
Materials.
are in most aerospace now weren't the technologies we used in the 60s and 70s and early 80s. So I think that's how I feel about it. It's just so pervasive in everything we do in my business that being in the standards work, you can really feel how much you get to touch every single thing we build. And
Mm,
of course, safety is, I mean, everything we do is safety. Especially, well, anything that carries human beings, but and not only that, but how safety reveals itself in our manufacturing operations.
right,
That's another big part of it. I mean, we talk about the safety of the vehicle and the people who ride the vehicles, but people who have to make and assemble the vehicle, they've got to be kept 100% safe too. We can't design a manufacturing standard that is in any way provides risk.
right. Wow. 40% is a significant number.
Mhm.
So, what does using standards actually look like in a daily aerospace work beyond documents and compliance?
Okay, let's see. So, we have, let's say, libraries that we maintain of standards because we use a lot of standards that are created by industry associations, such as, and the United States military has, a big resource of military specs and standards that go into our products. And they go into commercial products as well as military products. There's Aerospace Industries Association in the U.S. Publishes a lot of standards that are very highly used in our company, Society of Automotive Engineers as well. And I could go on, ASTM, ASME. I could list a bunch of companies, but
Yeah,
I would say there's 5 or 6 companies that do the bulk. But if I add it all up, we have maybe 200 standards providers that we use their
right.
standards in our products, and in how we conduct our business. Um, in addition to that, Boeing creates its own internal company standards when there isn't an industry standard that really does the job that we really need done. I need
Mm,
something just like this industry standard, but I need it with purple stripes instead of pink stripes. And so I'll have to write a Boeing standard to
right.
define that thing. And in our company, we have 200,000 of those documents, which seems like a crazy number. It's bigger than most standards libraries.
Right.
But the reason that number is so big is that Boeing has grown through merger and acquisition. So some of those were McDonnell standards, and some of those were Douglas aircraft
I
standards, and some
see.
of those were Rockwell standards and Hughes company standards. And so what used to be 7 or 8 different companies are all now Boeing. And those old products from before they were merged are still out there flying, and they need to be supported. So we've got this library. We have to maintain
That's
it.
a hell of a library. Yes.
And it's a big task. One thing my company has done differently than some of our competitors is that um, we've centralized our standards operations across the whole corporation. And so we don't have different cities have different systems for how you manage that. We have
Right.
centralized that process, and we can reach into each other's standards. And if someone working on an old McDonnell aircraft jet, let's say, can use a standard that is also being used on a 737 commercial airplane, at
Mm,
a different time. Though that library is shared, and the information is shared across the company on that, and as users, they get to speak out and say vote on changes to the standard and be part of the community that um, gets to interact with the people who we call them custodians, the
Right.
the the groups that run those the changes to the standard. So we've got a nice smooth system. It cuts down on proliferation and growth of standards because one already exists somewhere else in the company, and we get to share that a lot more. So
Wow. Very
um,
impressive.
yeah, so that is something I think really works well for us. And but so in so doing, getting back to your original question, so we've got to have these catalogs, and we've got to make these catalogs available to designers, to quality, to manufacturing engineering, to people who are on the shop floor. So people ought to be able to take a standard and go to a computer and type in a number and have that document available to them. In addition to that, because we have standards from so many different organizations, um, you have this problem where people say, "Oh, I've got a part number on my design, and I need to know, what is the diameter of this part, or what is, the material or the finish or something on that." Now, that
Okay.
won't be just the standard number. That will maybe be a complete long part number. And people who work in procurement or work in manufacturing, they don't know, is this an aerospace industry standard, or is this a Boeing standard, or is this a Lockheed standard?
Right.
They don't know. They just know they have a part number. And so this is where I put a lot of my own effort in my career has been breaking down the content of those standards and putting them into different databases so that someone can say, here's a part number, and now give me the dimensions, give me the
Right.
materials, and give me what quality instructions are appropriate for that. So a lot of what we try to do to make this available is we make catalogs available of the standards themselves, specialized catalogs to get into the granular levels of detail inside the standard without having to reinterpret it as a human every single time the question comes up. Um, Someone can walk up to one of our systems and say, I need a fastener, and it has to be 3 inches long, and it has to be made of corrosion resistant steel, and it needs to have a hex head, and some pitch of the thread might be important. And they'll put these features into the system, and then our systems can say, oh, well, I've got some standards from this group and some standards from that group, and I've got some old standards from Hughes Helicopter Company, and I've got this or that. And then we can find those things across the company. They don't know what standard they're looking for. They just can describe what they are trying
I
to
see.
do. And then our systems will tell them, oh, well, something like that is on this standard or that standard, or here's 3 standards that might solve your problem. And people who are not me don't need to know all the standards in the world. They're
Uh-huh.
just using something. It's kind of like shopping on a website, like, here Amazon is a popular website. You type in what you want, they'll tell you who's selling it. And that's kind of how our
Mm.
system, we'll tell you what standard that's on if you tell me what you're looking for. So that's another way that people interact with our systems to get to standards without knowing the standard that they're trying to get to in the first place.
Right. Pretty sophisticated system.
It's
So can
taken
you
a long
share an example? What?
time. It's taken a long time to build those.
Pretty impressive. So can you share an example where a standard clearly improved safety or quality and perhaps where it didn't fully match operational reality?
Yeah, we've got a story. Um, when you install a fastener, and let's say that all our airplanes are held together with millions of fasteners, right? And so installing these fasteners is one of the basic things we do at our company. And there's a measure of how much you tighten down the fastener called the
Right.
torque. And there are these tools called torque wrenches that you can apply to where the fastener was, and you can see how it gives you a number that tells you how tight that fastener is. And if you know, in most cases, you don't want to make it too tight, but you can't leave it loose, and we can't have fasteners working themselves loose once they've been applied to an aircraft. So um, the instructions for installing the fastener and torquing it to a certain value is um, involves a lot of steps and a lot of formulas to calculate it correctly. And so once upon a time in our company, we would just give this explanation to manufacturing to say how to calculate what the torque should be. And then the operator who's doing it would have to figure out what the number should be, and they'd apply it. And then the
Right.
inspector would come along and they would calculate it, and they would come up with a different number. And it's like, oh, because the formula is complicated. You had to look in three different standards maybe to find out all the values that had to come together to give you this torque value. And at that point, the when you manufacture something in production like we do, you try to pay attention to where your worst problems are. And the number one problem we had was getting people to agree on torque. And now we had this torque spec that was written in the 1940s.
Wow.
Um,
Right.
and a lot of Boeing, just to be honest, a lot of Boeing specs that we use today started out in the 40s when we were building aircraft to support World War II. And that was really the big jets when they started to really be manufactured. Um, anyway, it was the number one problem, getting the torque right. So we tried to figure out how to resolve that problem and improve the torque spec. We had um, different inspectors and different operators and the engineers who wrote the torque spec all together and try to work this thing out. We had 5 experts get together and figure out what is the torque in this case or this case or this case. And they never agreed. No two people
Mm.
agreed on what the torque was, and they all had some reason why the spec wasn't great. So we developed a system where we calculated the formulas, and we didn't leave it up to individuals to go look up different
Ah,
pieces at
see.
different places. We figured it out for them. So now you can, again, walk up to a computer terminal and it will tell you, how many inch pounds of torque, this installation should be or that
I
one.
see. Mm.
And now the people who give the instructions to the operators on our shop floor, they just tell them the number. They don't tell them how to figure out a number. They give you the number. And so um, that went from the number one problem we had to the number 300 problem we had.
Right.
So that was a big deal just in terms of making a quality product that was safe to fly, out the door. And there wouldn't be any debate over whether or not, we had done it correctly. And it was a major way to rethink of how the standard was written with the user in mind. And so, again, it
Mm.
goes back to the mission of IFAN. I'm a user of a standard, and this standard is poor in terms of how I have to understand what my job is. And so this is one of the things that's attracted me to IFAN is, it's the voice of the user, the voice of the customer of the standard saying we can do a better job with standards, but we have to listen to the user and not to the scientist who wrote the standard sometimes.
Exactly. Yeah.
Yeah. So that's my best story on bad standard,
Fascinating.
good standard.
Fascinating. So my next question is, when user needs are not expressed in standards development process, what are the real consequences?
Well, I'll give you another example. So now you mentioned that I'm chairman of the Digital Standards Alliance, and a lot of my career has been on trying to turn these documents into mm, interactive digital data.
Right.
And I've given some examples of that. When So now, let's just say in today's world, and not in the history of the time I've worked at the company, but in today's world, everything is going into a computer system.
Mm,
And all aerospace companies are designing their aircraft in 3D models, and we want to be able to take sections of the aircraft and run them through computer simulations, or maybe the whole aircraft is going through a computer simulation. And we're going to try different, you know, wind shears and different, rain conditions and vibration and heat and all the things that challenge, the safety of flight of an aircraft or individual parts and really bend them and test them and find out what their limits are in the computer system before we go out and try to actually build the
right.
thing. And then, of course, we'll still test the real thing, but you want to know as much as you can before you start cutting metal and making parts. So, by having this sort of a new demand that our standards have to be consumed by the computer system to be able to run those simulations. To be
Mm,
able to fasten a wing to an aircraft, I've got to have the bolts and the screws that we have standards for have to be digitally modeled in 3 dimensions, and the
I see.
washer and the nut
Right.
have to fit onto the shaft of the screw, and we have to be able to say, I know how tight that's going to hold, and I should know by computer simulation where it would break under which extreme circumstances. But those standards weren't written for this time in the world. Those standards were
Mm,
written in the 40s and 50s and 60s,
right. A
you
different
know,
era. Yeah.
a different era. And so they were made by for a person who says, oh, okay, I'm going to look up a number on page 3 and I'm going to carry that number back to page 2 and look up another table. And, it's a puzzle to figure out what is the exact call out I need to know to get the standard part I want, or what is the right, if I know a part number, how do I dissect it and figure out what is this made of? What is the finish on the material? What is the strength of this device? Those things, they take kind of an expert in standards to read the standard, and now we don't have those experts. Now the expert is going to be in the computer
The
system.
computer.
Yeah, and so our standards are not written for the computer, and a lot of what I do now is to say, let's rewrite these as digitally sensible where the computer can look at this and understand it. And it's a lot more work than just slipping a piece of paper into an AI reader. You know, there even AI finds this stuff very hard. And in our business, because safety is the number one thing, we don't trust AI to make
Wow.
those
Okay.
decisions. There's no way. It cannot get it wrong. Being wrong is not in any way imaginably acceptable under any circumstance. So, we're trying to build these things very so well structured that no misinterpretation, can be made. And
Wow.
and then from that, figure out those accuracies. Another thing I'll say is that let's just make it simpler. Um, when you go shopping online and you buy something, and usually the website will say, "Oh, people who bought this product
Bought another
often
one.
bought some other product." And so you can do that with these things. Let's say I have a bolt and I need a washer and a nut to put on that bolt. Well, those are 3 different standards. And so if I'm shopping, if I decide on the bolt I'm going to use, and I know other features of the joint that I'm trying to create, then the computer could say, oh, well, if you're using that bolt, then this washer would fit and that nut would fit. And they've got compatible materials and they've got the strength properties, that are normally used with this bolt, and it doesn't choose for you, but it recommend here's
Mm,
see if this is good for you. And this saves people a lot of time and it promotes the use of existing standards before people start looking around and shopping for other things to introduce to our production that that would be new to us and that haven't been tested yet. So we're trying to steer people as much as possible to proven, tested technology.
Right, right. So building on your response here to this question, have you seen a situation where user input changed a standard and made it much better?
Well, I do think that the story I told you about the torque was one example of that, where the users just said this spec doesn't work and we've got to start over again. And so that is probably one example you can think about. Um, I think where we see that generally the most is in standards for manufacturing processes, not
Mm,
so much buying a material or buying a fastener or buying a light bulb, but how to heat treat some material or how to install a fastener. And so when you're giving detailed instructions to people step by step that they're going to follow in the manufacturing floor, um, I think that's where we get the best feedback from people after they're trying this out and they're working on it. And we test this stuff out. We just don't write standards and throw them on the shop floor. I mean, we tested these things in labs and stuff before we actually put it into production. But just because it worked in the lab doesn't mean that it's convenient or simple for everybody who comes along the shop floor. One challenge I'll say is that our specs have been written, and this is historically. So I'll just say, we're an old company, and everything we do today is a lot better than what we did,
hmm
80 years ago or 40 years ago. But we still have some of those old standards out there. So some of these specs can be really complex, and it's like what I would call a choose your own adventure. It says apply this sealant, you know, to this level of a certain pressure capability.
Right.
And there might be 30 different ways to apply sealant on the sealing spec. And you have to go through this thing and figure out, oh, I've got, this is true and that is true. So then I'm going to go to page 8. And now you go to page 8 and
Wow.
you look up a table. And in that table, it takes you, it says, oh, okay, well, under these materials are the certain materials, and the sealant has to be frozen before you apply it. And then you go to some other page to go figure it out. And so I mean, we don't ask the person on the shop floor to figure that out. We have in my company a discipline called manufacturing engineering. They take the engineering document and turn it into some smaller level detailed work instruction. But every time they do, it's a whole new mystery to figure out how do I get to the very specific thing that the person has to do from this long, complicated spec.
Right.
And so my company is investing a lot right now in how to break those apart. That was probably a good method when we only had paper and you didn't want to have 50 different specs on how to seal something. But now, again, because computer systems and we don't need to have stacks of paper everywhere, now I can make these things more intelligent, more refined. I
Right.
don't need 90 different kinds of sealing in one document. I could have 90 documents, and who cares now. So we're doing a lot to
To
make
simplify the process. Right.
simplify the process. And a lot of that comes from the user saying, it's taking me all day to read your spec. And then if that person doesn't do it and they just pass it down the line, then the next person, now I've got 5 people that need to read the spec all day, or
Right.
50 people. And so, move that complexity up to the as high up the line as you can so you don't have lots and lots of people around the world trying
Mm,
to solve this mystery of what the spec is telling me to do.
right.
Yeah.
Yeah.
Now, I know I just want to blurt out something, people all around the world depend on Boeing aircraft for the lives of themselves and
You
their
bet.
family. And so I'm
Absolutely.
telling you stories that make you, I don't want people to think, oh, I'm not going to fly in a Boeing airplane because they're too complicated. That is, I'm just talking about how we improve business. These aircraft are
Hmm.
safe. These aircraft, are carefully, tightly regulated. Everything we do has a strong safety focus to it. So I'm just telling you, in the course of my 40-year career, there have been stories where I really felt like we've made a big difference in improving something.
Right.
But please don't think
I I
that
fully
I'm
understand
telling
you.
you stories about that I fly a Boeing airplane and I put my children and grandchildren on it every year.
I fully understand that. So, Alton, what distinguishes meaningful user participation for a mere symbolic or superficial involvement?
Well, let's see. That's really great comment. I think you see that more when you work with industry committees and they have a balance of stakeholders represented at those committees that write these specs and standards. So you
Hmm.
do have more people who are just the users. If it is a product that you're talking about, you'll have manufacturers at the table. You probably have regulators, government regulators, or military customers, involved in some of these committees. And so, and this is one of the things, you mentioned I'm on the American National Standards Institute Executive Standards Council. And this is one thing that we really look at when we accredit someone as an American National Standard um, publisher, is to make sure that they have this um, strong commitment to representation of users and the breadth of stakeholders that are there. And if any of those organizations fall down in that area, we'll take away their accreditation till they straighten that
Wow.
out.
Mm.
Um, and in the 7 years I've been doing this, we pulled a lot of accreditations, but they get the message quickly and straighten that out. No one's really left in trouble for a long time because it's not a hard problem to solve. You
To
find out who
solve.
your stakeholders are, and you make sure you really extend yourself to them and that you invite them to participate. But we can't have the manufacturers running the committees. We need those users
Mm.
in those things just as much. Um, and I would say in Boeing, we support over 500 industry committees where we're sending engineers or other, depending on the kind of standard it is, to different aerospace committees, sometimes more than one person to the same committee, because we might have issues where a helicopter and a satellite have different
I see.
needs. And so one person may not have all the experience that's needed to represent the breadth of our product. So, it could be multiple people, but there, it's again a super important thing. These standards are part of our aircraft design. They're the definition of our product, and they
Right.
have to be just as good as anything we design ourselves. And we have to assure that. So making sure that we're represented in those committees is a big deal. And we know from going to those committees, Airbus is in those meetings and Lockheed is in those meetings and
Right.
all the companies we compete with. It's the same thing for them too. It's just how our industry, really operates. Internally to Boeing, we don't really work by committee. We have experts in different technologies who will write a standard, but then it goes out for a very broad review and feedback, and so it's more asynchronous. You don't have a bunch of people gathered around a table because, again, in our place, these people are all over the world anyway. We're not all working in a building where we can just close the
In a
door.
centralized place. Yeah.
Yeah. Um, but we have processes for marking up the standard, for asking questions, for slowing it down, for saying this isn't ready and send it back for more work. So it's a we still get procurement and quality and manufacturing planning, all those just safety, ergonomics people, everybody of all these disciplines, gets a shot at looking at the standard, looking at what did you change from the last time, and how does that affect us? So, we have really it's a mandatory process. These people have to respond. We don't put out, if quality doesn't answer our question for can we make this change, the change doesn't go out till they say yes.
Right.
Yeah. So
Mm,
it's a very strict thing. We don't skip people. It's it's built into the process.
great. So we are nearing the end of our podcast. Alton, if you could tell standards developers one message about listening to users, what would it be? One
Well,
message.
yeah. So I would say, again, so much of my personal emphasis is on uh, the digital use of standards and how we're
Mm,
going to feed them into computer systems. And many standards publishers, they're just paper publishers. They don't really often
really?
understand,
Wow.
what they don't know what kind of system I'm putting their tools in. They don't know how much
Mm,
money I spend taking their standard and breaking it down into digital components so that I can load it into a computer screen that will let me do searches and that sort of thing.
right.
And so, um, and they don't know, the databases and things I'm going to feed with that data. So I would say that it's really important for them to know what happens to the standard after I receive it. How much money do I spend just using their standard, and how much extra time and trouble that sort of thing is. Um, at some point, and we're going to either have to say as a company, we can't use industry standards anymore because they don't speak to our use case. Our use case is that everything's going into these computer systems,
Right.
and your PDFs do not get me there.
Mm,
And if I've got to spend time and money to break your standard apart, to put it into a computer format that I can put into my own system, then at some point it becomes more trouble to use your standard than to say, I'm just going to write a Boeing spec that by definition is started out as a digital thing.
right.
And then I'm just going to work in an all digital environment. And then those standards publishers on the outside will either fall away or they will have to run hard to catch up. Now, I know they're not big companies. I know they don't have a lot of money. I know they don't have the kind of technology savvy that a Lockheed or an Airbus or a Boeing would have. But that is the future, at least in my industry, of
Right.
what's happening with these standards. And so standards publishers really need to understand our use case and the use case across our entire supply chain across the whole globe, uh, on where this is going. And they've only got a few more years, really, I think, to catch up. I'd be shocked
Mm,
if 10 or 15 years from now, we're still doing it like we're doing it today. I think things are going to speed up
to
and
transform. Yeah.
commitments will be made. My other guess is that it's not just aerospace. I think medical device manufacturers, I think automotive companies, I think oil and gas industry, they're all investing heavily in these, smart technology infrastructures to
Right.
consume that will consume these standards, and these PDFs are not going to make it in the future. They've got to understand the content. They've got to structure the content to be computer sensible, and so that's where I think they got to listen to the users. Now, the users have a responsibility to speak up. They can't just say, "Oh, well, I just hate this," and complain about it. They've got to go talk to their standards publishers that they rely on. Um, so it's a partnership, I believe, but the standards developers can't say, well, we can't afford to do that. If you can't afford to do that, you're going to become irrelevant, I think, at some point.
Right. So the big message that you are just described is that the ability to digitize standards is a mission critical for standard writers, right? If I can summarize what you said.
It's mission critical for us as users, and it's mission critical for standards publishers as well. Right.
Right. Very good. So this is a point in time where I thank you, Alton, for your insights, your expertise, and deep knowledge that you shared with us today. It's very valuable. And I would like to wish you much success in achieving your objectives at Boeing. Thank you, listeners, for tuning into the voice of standards users. I hope this podcast has benefited you because standards make the world go around. So see you soon in our next episode. Thank you, Alton.